Now, in this video, we look at the Lewis structure of the nitrite ion or the nitrite anion, having as its IUPAC name dioxonitrite 3 ion. But to do that, first we need to determine the number of valential electrons of this ion. Now, nitrogen is in group 15 on the periodic table, having valential electrons of 5. Now, oxygen is in group 16 on the periodic table with valential electrons of 6. Now, both of them are in the second period on the periodic table, and that will mean that the maximum number of electrons that the second shell can take is 8 electrons. So what do you think would be the number of valential electrons that the nitrite ion would have? So first of all, we need to count the valential electrons of this ion, which is made up of 1 atom of nitrogen and 2 atoms of oxygen. Nitrogen has 5 valential electrons and oxygen has 6 valential electrons, and we shouldn't forget that the nitrite ion carries an extra electron on it. So the total number of valential electrons that we would have to work with is 18 electrons. So now between the 2 atoms of nitrogen and oxygen, we need to determine which one to consider as our central atom when drawing our skeleton structure. So in choosing our central atom, we will consider the atom which is able to make more bonds. The more bonds the atom is able to make, the more suitable it is to be considered as its central atom. Oxygen has 6 valential electrons. It will require 2 extra electrons to get to 8 and achieve the octet. Nitrogen, on the other hand, has 5 valential electrons. It would require 3 electrons to get to 8 to make the octet. In that regard, nitrogen can form 3 extra bonds and oxygen 2 extra bonds. Now, the more bonds the atom is able to make, the more suitable it is to be considered as the central atom. And in that regard, the more favorable host it would be to other atoms to form covalent bonds. We should also take note that the electronegativity value of oxygen is 3.44. That of nitrogen is 3.04. Now, the lower the electronegativity value of the atom, the more favorable and more suitable it is to be considered as the central atom. So for nitrite ion, nitrogen is more suitable to be considered as the central atom. So with nitrogen as our central atom, we're going to create a skeleton structure that will connect the atoms to each other. Now we're working with 18 electrons, so we're going to distribute the electrons on the atoms to satisfy the octet rule, with each line representing a bond made up of 2 electrons. So we have 16 more electrons to distribute. That is 6 electrons, 8, 10 electrons, 12, 14, 16, and 18 electrons. Now with this structure, this oxygen atom satisfies the octet rule because it has 8 electrons, 6 non-bonding and 2 involved in the bonding over here. A similar arrangement with this oxygen atom. However, this nitrogen atom has 6 electrons in its valence shell, 4 of them involved in bonding, 2 involved in this bonding, and 2 other electrons involved in this bonding, and 1 lone pair, which makes 6 valential electrons for this nitrogen atom. And so this nitrogen does not satisfy the octet rule, and this nitrogen atom will not be happy. And so this entire Lewis structure will not be the most favorable one to consider. Now, if this lone pair is converted to a bond, and likewise this lone pair, we're going to have this Lewis structure. Now, with this Lewis structure, the octet rule is satisfied for this oxygen atom as well as for this oxygen atom, because each of them has 8 electrons in its valence shell, 4 non-bonding electrons, and 4 are involved in bonding for this oxygen atom, as well as the same arrangement for this oxygen atom. But the nitrogen atom over here has 10 electrons in its valence shell, 4 in this bond, 4 in this bond, And we have one lone pair over here, making a total of 10 electrons in its valence shell. Now, for this Lewis structure to be correct, nitrogen should satisfy the octet, but it has 6 electrons. And for this Lewis structure, nitrogen has 10 electrons. So since nitrogen is not satisfying the octet, both structures are incorrect. Nitrogen should not have less or more than an octet. Now let's consider distributing the 18 electrons with the target of ensuring that each atom has an octet. Now let's convert this electron pair into a bond. So we have 6 electrons involved in the bonding, and that will mean 12 electrons to be distributed. So with this arrangement, this oxygen atom achieves the octet, just as this oxygen atom also achieves the octet. Nitrogen also has an octet, and all 3 atoms will be in a happy state. Now let's verify the formal charge on each atom. Now for the formal charge, we will be guided by the formula . So V subscript E is the valence shell electrons of the atom minus the non-bonding electrons minus half the bonding electrons of the atom. Now for this oxygen atom, oxygen has a valence shell electron of 6. It has 4 non-bonding electrons. Then we have 4 bonding electrons over here. So for this oxygen atom here, its formal charge is 0. So that is for the first oxygen atom. Now for the nitrogen, nitrogen has valence shell electrons of 5. Now this lone pair is not involved in the bonding, so we have 2 non-bonding electrons. Then we have 6 bonding electrons, 4 here and 2 here for nitrogen. So nitrogen here also has a formal charge of 0. Now, the formal charge on this oxygen, valence shell electrons of oxygen is 6. Now, how many are the non-bonding electrons? There are 6 with 2 bonding electrons. So the formal charge on this oxygen is -1. So this Lewis structure would be the most favorable to be considered for nitrite ion, since all the atoms involved in the bond satisfies the octet rule and are happy. Alternatively, if this lone pair rather becomes converted into a bond, we could have as our Lewis structure in which case, when applying the formula to determine the formal charge on each atom, we could then have to be considered as a possible potential Lewis structure for the nitrite ion, where all the atoms involved in bonding are satisfied, making a stable and a favorable Lewis structure for the nitrite ion. So the double bond can be on either oxygen. This means that the real Lewis structure is a resonance hybrid where both nitrogen-oxygen bond are equivalent in length and will have this shape. So we can have 2 resonance structures for the nitrite ion, where the actual Lewis structure will be a hybrid of the 2. So this is the end of my video. Thank you very much for watching, but keep watching.